It's time up, so we can begin. I thought I was dreaming. Yeah? So last time we ended where? Where did we end? Huh? I was cruising. It's like you have an accelerator with gears. Okay. So first of all, you have to drag and drop the database to the graphic interface, and also drag and drop the extensions for this. But these, they are not important. So what you do is, I can just reset the graphics. I just remain with the 4 IDs. Okay. Then after that, you have to composite the mineralized zone where the mineralization was captured. You have to composite it. So what you do for you to composite, you go to database, then composite database, then composite. Just drag the database is just important. The one that is important there. Then composite. Yeah. Then after composite, you go to downward composite. Database composite, downward composite. Bench elevation, you can do composite by bench elevation, by grade constraint, by graph constraint, geographic constraint, or those other methods. So in this case, we use the downward composite. Okay. Then it says define the string file to be created. You have to define the string file that you are going to create. So I can say composite 1. Okay. Here where it says define the string file to be created, you click on the drop down, then you type in the name down there. You give it a name. Then the number that you put in front here will come in. Okay, as the ID number. Then string depends the string. If you change the string, meaning it will take that color as the default for the first string. Okay. Then a composite range, depending on the composite, at which meter level they were taking the composite, the sampling length. If it was 1.5, 2 meters, 1 meter, this is the composite length which is here. Okay. So for example, if we used 2 as our composite length, meaning it has to be 2 there. Then determine the composite length by fixed length or best fit. You use the fixed length. Then maximum percent of the sample to be included, 75%, meaning this is 75% of that 2 meter is the one it will capture from there. So if you were to say 75% of that, 2 times 2 times 0.75 will give you 1.5. So 1.5 of that 2 meter is what it will add in that composted string. Okay? Then define the zone selection method. So no selection method, meaning it doesn't depend on any constraint. But if you were to use multiple zone, meaning you have maybe the transition and the flash, maybe the flash and the transition. Okay? Those, George, you know them very well, you guys. Those things of those transition, oxide, whatever. If there were that constraint, so you can start from the end of the transition to the flash, composed just that there, it will compose from there. No, I'm saying like if you know the geology of that area, you have defined it, not so. You have the oxide, you have the transition, the flash. If you know them, then you can use this multiple zone, okay, as a constraint. But you don't have it, so you use non-selection. Then zone from zone 2. This one, you can start from the end of the O or from the collar of the O to composite. So in this case, you just use it non-selection because I don't have those. If you know them, you can use the geological constraints. Okay? Then where are you going to composite from? You are compositing from the assay, okay, which is the copper. So you use the assay. If it is the geology, you can use the geology, meaning the constant for geology. Now, here you choose the field that you are going to compose, which is the copper. Then this one, option weighted fields, leave it unfilled because you don't have a weighted field. Unless if you add the specific gravity inserted there, you can use the specific gravity. Then default. Then exclude limit. So meaning anything that is above 1 will be reported with a different string number. It will give it a different string number, the exclude limit. So that one also leave it open. Then you apply. This one also leave it, don't do anything, just apply and wait, it will process. Okay? Everything is okay. Okay, so it is saying it will pop up these statistics. It will give you the minimum, the maximum, and the number of balls. So the mean it is saying is 0.77. Okay? And total is that. There is that statistics that pop up there. 94 balls were processed. Okay, then I can just clear this. If I bring this composite one, okay, you have created a different string, which is this one. It has composted. Okay, so this one also can help you to create your block model. Okay, now what will happen is when you do a block model with that, you have not done the geostatistics. So the blocks that will be having the values, just the blocks that are direct with the ball, okay? Away from the ball, it has not been calculated. The value has not been estimated. What? Huh? The composite string. I dragged and dropped it. Yes. So what I mean is the values, they are just direct where you sample them from, not so. Meaning between those balls there is nothing that was captured. That's why you need statistics to calculate what is wasted and what is between. What? It's not showing. How it is not showing. Did you give it a name composite? So how can it be composite if you gave it a different name? Huh? Now this, we'll go back after we have created this. After we have created this, we'll go back to the Orebody strings that we created. The sectioning strings. Okay? Hello, load the section strings. The Orebody, whatever name you gave it. Okay? Now on these Orebody strings, this will not be like yours. This is mine, you have your own. Okay? So what you do is, last time we didn't create the solid for this because you need to calculate the volume. And with the volume, that's when you can calculate the tonnage. Okay? So now what you do is, this is what we are doing last week. You go to solid, triangulate. Now I have two segments here. I'm having two segments. 1, 2, 1, 2. Different segments at the same place. So what you do is, first of all, here where it is written string number, you can change the string number if you wanted to change the string number for anything that you are digitalizing. But in this case, we are dealing with solids. So triangulation, triangulate between segments. Okay? Then I'll give it 1, isolation 1. So object number is what will define the color. If I was to put 8, it will be red. Okay? Then I choose this one to that one. Okay? Then I will escape. And I will start again so that it will leave the case and not to go back to the first solid it has created, because there are two. I have to create two separate solids at the same time. If I just continue, I go down, it will pick the last point there as the end point and connect it to the other segment. Yeah? I'm saying I was digitalizing, I was triangulating, okay, from this one to that one, okay. Now, if I was going to go direct to this segment, it will connect the other segment on top to the one down, and that will bring conflict. So it's better you escape, you release the cursor, the command. It stops that command, then you enter again, start a new command. Okay? So that you start from a new one again. I'll click down there on this one, then on that one. So that these two, they are separate. If I was going to continue direct, from top to down, it will connect the top one to the down one. And that will bring conflict. Okay? This is different with what data mine does. Surpac creates the triangulation on its own. For data mine, you have to triangulate yourself. After you create the cross sections, you have to start triangulating again inside to connect everything. But Surpac calculates on its own. That's the only difference. Now we have two segments here. This one and that one down there. Not so. We need to connect them to this one. Yeah? So you go to the same solids, triangulate one segment to two segments. Now put the tessellation, which was the object number 8, tessellation 1. Apply, apply. Then it says select the parent segment. The parent segment is this one. Okay. Then it says select the first child segment, will be that one. Okay. And the second will be this one. Okay. So it will be like that. There is a O inside here. You see that there are two. There is a O there and there is a O there. Yeah? Which bit then? Your own is different from mine. If you are having one string, connecting it to the other, it's just direct. Triangulate the segment. But if you make a mistake, you're supposed to. Are they the same? Are you sure they are the same? They are not similar, they are different. I have two segments. I have this segment on top and I have that segment on down. They are not the same with what you're having there. I didn't bring one down. That's how I digitalized it. I didn't bring one down. It's triangulate segment. You are not connecting two segments to one. Maybe it's Zoom. Let's connect. You will fully come.
So, are we using triangulate between segments? Is it between segments?
Between segments, yes. Like here, okay. We have these two. Watch, because you are there. There are two segments. There are one segment. There is a one segment here, and there is a segment here. Those is one segment, one segment. The other case, I was having a segment like this. I have a segment here. Whichever segment it is. Okay. Then the other one is down here. Yeah. Then I was connecting it to one segment, which is there were two segments also. Okay. So I connected this one to the top one. Okay. Then I triangulated also this one to that. That's what I did. These things are too simple. Huh? Someone who was intelligent, he made this software, of course, was tedious to do that job. Now you just to follow what he did. What's the problem? Laura. Just undo.
Like this.
Undo. Yeah, something like that. That's what you are going to create. Which processor? I said, maybe you were not following the previous classes. Yeah? When I was digitalizing, I separated. There is a zone where the mineralization was not captured. I left that so that I don't dilute my ore to avoid overestimation. That's why I'm having two at the end. Okay, I'm avoiding overestimation between this segment and that segment, meaning there was no ore that was captured. The copper grade was not captured. So I left it. Yeah, I dicterize what is down and I dicterize what is on top. That is what is here. Now you just dicterize one segment, one segment, one segment. That's different. It depends on your assumption. Me also, I just confirm what you have done if it is correct. Because I don't want to have overestimation and I will be the person to be questioned. I'll just confirm what you did. If the tonnage, they are tallying. As it is the Orebody, if I can model the Orebody there, yeah, get me, if I can model the Orebody there, with the specific gravity, I am done. I have my tonnage, not so. Now you deal with the copper grade. Yeah? That's how you multiply it with the 0.02 whatever. Then you get the amount of copper that are in that whole body. That's what you are interested in is everything there are blast. Okay? I'll drill and blast. So now we have these two. This one is one and that one is one. So I'll just go direct. Sorry, triangulate between segment. Okay, then I'll just select this segment and that segment. Okay, then I'll move to the next, that one, that one, that one, because these, they are one segment, but if you reach at the point where there are two, one on top, one down, that's where I do it differently. Okay. So for example, again, I have a case where I have two segments here and one parent segment. Okay? I have one parent segment here. Okay? Then I have two children segment here. Bifurcation. So there you have to do bifurcation method. Therefore, I have to go back to triangulate, then one segment to two segments. If I had more segment, meaning, for example, 3, meaning I'll go for one segment to many segments, meaning there are more than 2. Okay? They can be more than 2 segments, maybe 3. And there the mineralization wasn't captured. So we'll go for that one. Then it will ask us, select the parent segment. In this case, the parent segment now will be this one. Okay? Then you go to that one. Then also on that one. Okay? Yeah? Again, this will be now our parent segment, and these two, this one and that one, will be the children segment. So we have to connect now this one to those two. So I have to go back to segment, triangulate, 1 to 2 segment. Okay? Select. Okay, apply. Then I'll select this. It's my parent. Then I'll select this one as my first child segment. Then it will move like that. Okay? You are laughing on me. That is Padre Io. In short. The parent. Me, I was taught the parent is the Padre. The Padre meaning is the parent. Yeah? Then the children meaning is the Io. So those two, they are Ios. Yeah? So I don't care. Even if you laugh on my language, I don't care. But I can understand better things than you. Yeah? So you have now 2 here. So we have to cross these two. Yeah? It's the same thing that the other guy did. We just have to go back to solid, triangulate between segments. Then select this one and that one. Okay? Now you have finished triangulating between the two segments. Okay? It's open. That one's open. How do you make it open? Yeah, that's where we are going. Now, this, when we are creating, we were triangulating between segments. Okay? Surpac doesn't calculate the volume when the solid is open. So this solid is open. It's hollow. Inside is hollow. As you can see, there is a O going inside. You can see. So what you do now is, if you go to solids, triangulate, there is inside the segment. Triangulate inside the segment. Okay? So if you go to inside the segments, I'll put the same object number and the selection. Then, excuse me a bit, it's going to be like this. Then I'll enter. Okay? So inside the segment. So what you do is, now you select the ends of these segments. So we'll select this one. You see it has crossed that one. Then we'll go to this one. So it is refusing, so don't worry about that. We'll just position it well. Then I'll go back to solids, triangulate inside. Okay? Then I'll select this segment. No, something is wrong there. What? That. Okay? If you make a mistake, it will triangulate inside. It will pick a different point inside. And that will avoid the solid to be validated, because you have to validate it for you to calculate the volumes. When you click there, it will close. Then you have to move to the other end. Okay, this is our other end. Then also this one, we can go to triangulate, then we select the segment here. So what it has done, it has not triangulated the last, it has triangulated the one which is inside. So in this case, I'll undo. Okay? Then I'll position the Orebody well. Okay, somewhere there. Then I'll go back, triangulate inside, apply. Then I'll select that. Now it has crossed outside. You can see it's outside, not inside the solid. It's not open, that one is closed now. It was open, I'll just close it. So, if you close, you can't open. If your digitalization was not done well, that's where O board or blue was the Y Z. Okay? The balls were almost in a straight line. But if you use the X, Y, they were a bit apart. So in that case, you find that you have digitalized a lot of strings at the same nearest point. And those, when you're going to triangulate, you find it is giving you errors. Yeah, so it's because of that. So the best orientation was there. Meaning you have to digitalize again in the OIZ. Okay. So now after that, you can save this. Save string and DTM. Okay. Now it will change here. The output format type will be Surpac DTM file. Yeah, save, just save. Surpac DTM file. Now Surpac thinks that you are now creating a digital terrain model. Okay? You know, there is a digital terrain model and digital elevation model. There are two different things. Now here it considers it to be a digital terrain model. Yeah? Then you just apply. Now what happens here, you have to know this. What happens is, hello, excuse me. What happens is, we can see here we have O copper 1, not so, and O copper 1.dtm, O copper 1.string. What happens there is, if you delete this string, meaning the DTM has been damaged, you have to redo the string. This is the father of the DTM. In short, you can't have a DTM without a string. So the string comes first. Now I can pull alone the DTM and it will be like this. Okay? Meaning that will be now my O board. Yeah? Now for you to confirm that that O board is correct, you have to go to the solids. Okay? Solids validation. Solids validation. There is that solid repair. Leave it out first in this case. So you have to go validate object isolation. Okay? Click on that. Then it says report file. We want Surpac to report to give us a report about that board. Okay? So you type in that maybe report validate 1. Then the range and the isolation range, leave it this 1 because the way it is, because it is, we are using 1 isolation and the object range, there isn't a difference in color. So meaning we are using 8, 8, 8 everything. So leave it 0 open. Okay, if it was having like, when you are doing the isolation, like you are doing the triangulation, you can use different colors for each section. And that, when you are going to validate, you have to add it here. The number of colors, the range, the 32,000 strings that are there. Okay? So in this case, we are using 1, so we leave it open here. Then attempt to autocorrect problems. If there are no problems, just leave it the way it is. Select valid object to solid. Okay, not to void. Void meaning it's open. We want it to solid. Then you apply. Okay? So, this pop-up, this is a report that the object ID, the 8 we were using, is this one, it pops up here. Then the isolation, we are using isolation 1. Valid, the object is valid. Then open or closed, it is saying it is closed. Okay? Then connected total, then this duplicate 0, 0, 0, 0. Meaning your O body is correct. You can calculate the volume of that O body. Okay? If it has given you invalid, open, meaning the O body is open somewhere else. Okay?
Is there a way that you identify that? Let's say I just got it.
It's a bit tricky. You can't, first of all, you can't do a repair on the solid. You have to do a repair on the segment, on the string itself. The solid, you can't repair it. It's a bit tough. Yeah? I don't know. That's what you have to do. So, okay. Now, what you do, sometimes to solve that problem, that's where you go to solids, validation, then solid repair. Okay? You go to solid repair. But in comes we do not close it. You see where it is open, where it is showing red, meaning it is open in all those places. Now what you do is, since that thing has opened for you, so choose this, the solid repair, it will bring this dialog. Okay? Then if yours is having problems, it will show in red colors where it is open. So to correct those problems, click on this, come on boy, click on this button where there is a green tick. Click on that one. Yeah, just click on that second one. So it is still having problems. It's a bit tricky. Yeah, but your one will not close. It has a lot of issues. Even this one has a lot of issues. All of them, they have a lot of issues. It's the way you are utilizing. This one you can close. Just solid. Solid, validation, then solid. There. So it is tricky. That's an example you can solve that problem. So be careful orientation of how you take where the balls more likely to be in a straight line. It doesn't mean that you have to use, excuse me, it doesn't mean that you have to use always the x, y. Like I said, I didn't say you have always to use the xy because we are using xy. That's why I gave you that data. It is you as a geologist to suggest which correct orientation can I use. Sometimes you use the zoom to extent, okay? Sometimes you just use xy. They are oriented because it's an ubiquitous type of drilling. Orientation is the pose, they must be in a straight line. In general, that I think the section method that you learn is the practical way. The balls, they are always in a straight line, not so. So those are the balls that you are dictalizing. Now if you dictalize this ball is near to another one and they are almost in a straight line because it is planned, not so. Then you dictalize them wrongly. It will give you those problems. The solid. What does it mean if something is solid?
No, I mean it's open.
It's open. Closed. open, and this we saw it. Eh? Very bad examples. Okay, so let me just reset my graphics. Okay. Okay. Now we have this whole body. So the idea of you validating that whole body is this. You can go to solids, okay, solid tools, okay. Then those solid tools report volume of that, okay. Then there is this location where are you going to save the report. Then it comes to the ID. The ID is the number that you put at the end. Then the report format. Those are the report format that you can produce from there. So the note, the CSV, which is the comma separated part, the HTML, those internet things, web. HTML the same. Then real text file is like in Word form. Word can open, then PDF and PS. So the best is CSV, because CSV can allow you to calculate other calculations. Okay? The ID number is the number when I type the name here, volume 1. Okay? The 1 will come in the ID number. Okay? Then the decimal numbers that you want. Now, what is happening here? Excuse me? What is happening here? If you know the levels, like us, what we do, we want to know from this level to another level, what is the amount of O that is there? We use the intervals or the elevation. This elevation to that elevation. What is the amount of copper that is there? Okay? So that's where I use the elevation and the intervals. Now, if we want to report the total of this, we just, sorry. Okay, I'll put volume 1, apply, CSV, then apply. Okay, you wait, it's processing, it's calculating the triangles and forming the volumes, then it will give you the total. For you, if it is not crossed, it will not give you, it will pop up another report that it is giving you an error. The surface area, it can give you. The total volume is that one. For me to give me the total volume. If it is not crossed, meaning you can't proceed with your calculation, you have to go back and do the thing. So you have to be careful the way you visualize. It's open somewhere. The surface area can come on, but the volume no. The volume no. Yeah? So that is the total volume of that whole body. Okay? Question? Mafunzo. The location is the name. Type the name there. Yeah, just type there in the text box. Then put a number at the end. Okay. So this whole body, see what happened is I have this composite. That composite we created. There are these strings that are outside the whole body. Okay? There are these strings outside the whole body. So you can clip those strings inside the whole body so that it remains just what is inside. That can become now like the whole body is the constraint that you are using. Okay? Also, the same string, we can use it to create a block model. Okay, so what you do is this when you are creating a block model, because this is where we end. If you wanted to know how to calculate and populate it with the geostatistics, you can do it later. Yeah, I'll end there. We'll learn more when we go to the math. Yeah, you have to understand geostatistics to populate it. Okay? We are going to populate it, but the only places that will be having the blocks with the grade for copper will be only the blocks that are on the drills or the bores, as they say. Yeah? So now what you do here is this string, you can right click on it, then say edit. Right click on that string, you populate it, then say edit. You have done? It is opening this information. Now, you have seen this 0000111. That is the string, the first string where it was getting the data. Also, we have here 2. Okay? String 2. Then it has string 1. This is the string that we are having here. When we were populating, it was creating what was exceeding the limits to be blue. Okay? Then white as what was on the limits. It is white. So the white is 1 and the blue is 2. Okay? That is what it has done there. So what we do here is you can reserve this to avoid savers, to avoid problems when you are going to populate the block model. You save this, save as composite. I can just say block model. Hello, I'm a bit busy. Hello? Block model. Then you save at the end, type .csv. Okay? At the end, type no, remove that dot there. It's confusing. So delete the name and give it a block model.csv. What is it? Funso. What I wrote well on the report. I just gave it a name there. You can give it even your name or junior, but it has to be specific to something else. So now you are still there. We are doing something else. Hmm? Okay, so I'll save it as .csv. Then yes, okay. I'll close that. Now I have this the .csv. I'll run the Excel. Okay, that file, so that you can edit what is not important and change the names. I can remove this, the composite here. I want to remove it. Okay, I'll remove these 2 lines here. I'll remove them. Then I can just insert 1 there. Okay, are we together? Just delete what is not important. Then I'll say that is the y-axis, which is the northings. Then this is the eastings. Okay, eastings, the surface reduced level. Then the copper. Copper is in here. Then you have the ball ID. ID. Then you have 50, 52. You understand what it means here? 50, 52. Huh? Explain, man. You are in the right direction. You are in the right direction. Explain. Yeah, it's, when we are compositing, we said it will be moving 2 meters. It was composited 2 meters. You see that? So it started from 50 to 52, which is 2. Yeah, the interval. So that is what is there. So we can say here from and to. Then interval. Okay. And here there is nothing that was reported. I can just remove this. Or you can put the specific gravity if you want. Maybe if it was 2.6 whatever SG. Okay, there. Then you have this useless data here down also. I'll remove it and save this Excel. Okay. Yeah. That's it. That's good. Mukusira. Oh. Okay. When? So now what happens here? There are 2 ways of creating a block model. There are 2 ways of creating a block model, but this is the simplest. The other one, you have to calculate the maximum x, the easting coordinate, the maximum northings, the maximum elevation, surface reduced level, and the minimums. Okay, the minimum values. But there is another way of creating a block model in a simplest way. Okay, so what you do in that case is mukazi following. What? My dear, if you can't follow, we can't be going behind every time. Huh? But why are you not following? Because the way I'm doing it for you, that's the way I was being taught. And ways. So I don't know how you want to be helped. Maybe I'll just do my course so that it will come up and I can talk too much. So for those who populated, if you didn't populate Nigeria, that's one problem. For those who populated and they have educated the Excel, what you do is this. You go to files, okay? Files, then import. Files, import. Yeah? Files, then import. Okay? Then data from a file. Okay? Then it will open up this. It is saying text file. The text file is the CSV file itself or a text file. So I have that block model, which is this one, not so. I'll open it. I'll click on it and open. Okay? Then it says output to string file. The string file that you create. So that string file will be block model. Okay, block model. Okay, then save. Are we together? Then there is ID, that is the one I put there, string number, it will be 1. Then number of header lines, 0. Don't put an header line. Then number of description fields, 0. No description field. Then delimitator. A delimitator, it can be a spacer delimitator or comma separated. Sometimes you find a point, or I don't know if it is the semicolon. Okay, so you check in the delimitator as to be comma separated. It will bring it here. Okay, then log file error. So the error will be reported in that one for log file. Then you apply. Okay. Now it will ask you this one. It wants to calculate now by itself. It will calculate the maximum, the minimum for all the three: the x, y, and the z, which is the northing, the easting, and the surface reduced level. It will calculate. So now in that Excel, you have to specify, like what we were doing last time when we were doing ball logging. You specify the field number for the y-axis, the x-axis, and the z. So the y in that CSV file was number 1. So you put 1 there. X was in 2, and z was in 3. Okay? Then you say apply. It has done that. So it has created now this. Okay? It creates this. Something similar to that string that we created, we populated there, if you remember. Okay? Now, this line going down here, is considering it to be a 0 point. Okay? So that line, we usually delete the point here. Okay? You delete that point down. You're following? You delete that point, escape and save that string. Overwrite. Yes. I can reset my graphics. Then now, there is that menu, block model. Okay? So you go to block model. Now you say block model new. Okay? Now you say if it is KCM block model, you can put KCM block underscore block model 1. Apply. Okay? Apply and create. Yes. Apply. Okay? Description. Here. If you are join something, you can load. If you want to write maybe KCM East, KCM East Orebody. KCM East Orebody. You can write a description there, so that to show that it is from the other side. Then come down, define the model using minimum and maximum coordinate. Then there is origin coordinate extent. This one, if you know the origin and the extent, you use that one. But we don't have that. We want it to get minimum and maximum coordinate from that string we created there. Okay? Then you come in extents. So you can say now, get extents from a string file. That string file that we have created, the block model. You just check in here. Okay? You check in here. It will change the dialog down. Serious, huh? Okay. Then extent strings. So the drop down here is for that. You click on the drop down, then choose the block model string. Okay. Open. it has calculated the minimum and the maximum. If you want to confirm that those are the minimum and maximum, you can go to the CSV file. You can run your CSV file. So we have this block model here, the database in the CSV file. I can go at the end, okay, of this. Then I'll enter, then I say maximum value, then I will go on top here. I'll select this, take it down. Okay, this spends a lot of time for you calculating these things. That's why I don't like this method. So this value will be the maximum. So we can pull this one to that to get the maximum also for this one. Then also we can pull this one to there to get the maximum for the surface reduced level. Then you come down, you say equals min. So the minimum value also you have to go up. Okay. It ends in this cell. Okay. Then now enter. It is saying 0. Is there a 0 number there? There is a 0 somewhere, meaning there is a 0 here. That is 0. I will remove it even. I don't need it here. It's the 0 that was giving us that side, that point. It's because of that. Okay. I'll remove it. Then it will give me a minimum, which is reasonable. Okay. Then I'll pull this to that. So if we check these values here, I go back to this one and I pull this one this side, okay? This is 721. This is 721.489, the minimum. Okay? Then this is minimum 1443. It's the same as that. The same as this. Okay? It's the same, not so. These ones also, it is the same. They are those. Okay? So instead of doing this here, you just create that string, then Surpac will calculate it there to avoid errors. Okay. I don't need these values here. So after that now, you are okay. So what you do now is, there is this user block size, okay? The block size mostly, the surface reduced level is shorter than the XYZ. In the XYZ you can put 5, 4, 3, but it depends with your processor. If you can reduce the blocks, the better with the estimation. But the smaller the blocks, the slower the computer will process the data. Okay? That's the idea. So here, for example, we can say our blocks will be of 6 meters in the eastings, in the northings, 6 meters in the eastings, and 3 meters in the surface reduced level. Okay, then after that you apply. It will pop up again this dialog. Doesn't matter, then just say create the block model. The block model has been created. You can display it from there, meaning it's the block model for the entire area. Okay, now this block model has nothing. There is no copper in any of those blocks. It doesn't have anything. So what you do now is you go back to block model. Okay, block model, attributes, block model, attributes, new. Okay, now in this new attributes, that's where you put the copper. If you want to populate the copper, then the type. Here use a float value, which is a bit a smaller value, but it's a decimal point, a float value. Use a float value, decimal point maybe to 2 decimal point. Then the background value, we don't need to put a background value. Then the description, you can put copper. Okay, then tab, I don't want this, I just want the specific gravity. Okay, also it will be a float value of 2 decimal places. The background value, it can be 2.6 because I know it there. Then you can say specific gravity. Then apply. Okay, after you apply, you go back again to block model, import, block model, import. Okay, then text. Okay, it will bring this, meaning I have to go now to that CSV file we created, open it. Okay, to come there. Then regular block size, check it in so that the block size will be regular. First point, here leave the first point, then apply. Yes. Okay, it will bring this. That is the CSV file that we have there, and we have the attribute column for columns here. So what you do is, in the first column here, you match this with what is in the attribute there. Okay, so the attribute 1, what is in 1 there is y, so y. Okay, you go to 2, what is there is x, not so, then z, then 4 is in 4, copper. Okay, then the specific gravity is in 6, so you jump 5 since we didn't add the ball ID. Okay, you jump 5, we go to 6, specific gravity. Okay, then after that you say apply. Yeah, it will pop up this message. Now what happens here is, if I was going to add the 2 bars for a block model here, I want to know only the blocks that has copper. Okay, you can come now to add graph constraint. This one, add graph constraint. Then click on that one. It will bring this dialog. So on this dialog, you are dealing with a block model. Okay, a block model. Then is copper. I want the blocks that have copper is greater than 1 or 0. Greater than 0. Then add. Then you apply here. It will just bring the blocks that have copper. This is what I was saying. It will just populate the blocks that are near to the ball, because that's where it was sampled. That's why you need to understand the geostatistics so that you calculate what is on the middle between these 2 points. There are geostatistical methods in this Surpac where you do estimations. So those are the estimation methods. Okay? Then on this block, if you wanted to know what is the copper in this block? You can come here, there is a inquire, identify block value, then you click on this block. It will pop up. The copper is 240, then it's saying 45, 40 something, meaning there is a mistake. It was summing up those values. So there is a mistake there. You have to remove it. Can't be that way. So the copper is 2.5 and the block, the coordinates are those and the block size is there. Okay? That's the idea there. Also, no, I've made another mistake here. Okay, now what I'll do is show. Okay, I'll just go to graph control, then I'll add blocks. Copper is equal to, copper is greater or equal to 0. I want to return everything back. It's refusing. It's the problem of this thing. Okay, remove constraint. I've removed the constraint. Then I can save this block model. Let me save it. Okay. It has been saved. Okay. So this block model, it has even the west where it was not sampled. So you can constrain this with the Orebody model. So what you do is you go back to block model itself, or you come to add constraint. Let me see. Just here, the constraint. Then the constraint will change to 3D model. Then we will choose the 3D model, which is OCAT. Okay. Then we'll add this here. Then apply. Okay. Meaning this is what is inside the Orebody. Those are the blocks that are inside the Orebody. Yeah. So this, you can save it. If you want, you can save new constraint. Say new constraint. Then we say 3D model. Then the same 3D model, we pick it, open, add there. Then apply. Okay. Then you can save this constraint. Save the constraint. I don't want to overwrite that. I'll save the constraint from here. Save current view graph constraint. You save it, maybe constraint or inside. Or inside. Okay. One, then apply. Or inside. Let's do it. Let me do this, I see. Refresh. Okay. The O inside is there. So if I was to say reset graphics, I bring the KC block model, display it here. It will come in full. Okay. Now I can just drag here that constraint and it will go back to that area only. Okay. Hmm? But guys, you said you wanted to learn and you seem not to be interested. And you know what it is? If someone you are putting your effort and someone doesn't want to learn, it's like you are stupid. That's how it seems to be. It's better you waste time and go dance in the street. Or tutaenda kuchigubi kucha usiku twabina kuja basiri la pamoja. No, this is too simple. It's the simplest thing that you can find in education. Yeah, but when? Quando? Hasta quando? Also, you know what happens here is if I was to do this, if I was to do this like the same graph contract we are putting, block, copper, okay. I want it to go to what is greater than 0, add, apply, okay. These are the blocks. You can color by attribute, okay. Then scan. Let me say copper, then scan, okay. It will bring those colors. Then apply. If you want to know the blocks that are having different grades, okay, you can color by attribute, meaning the blocks based on the color, they have different grades and they will be given a color based on that to give them a color like that. Yeah? Yeah, you know where to go. And me, I would know also which block should I start with to extract. Yeah? It's extracting, not black. You like blasting? Drilling and blasting. You can't blast without drilling. Kim has done mine engineering before, so you can't blast before you drill. Okay. So, any question? Any question? So far? Yeah? For? To do everything. Less than an hour, I'll finish. Yes, yes. From the scratch. Even if you give me data mine, I'll do the same thing in less than 1 hour. I'll not take time. I even know there are shortcuts to do this. Yeah? There is a shortcut way of doing this. You can make a macro, what is called a macro. I can learn it, but that is not good for any purpose. I can run it, it does everything, then I can edit. If you know programming language called TCL, you can edit that TCL language. Then it will start running. Okay? It's running, we record the macro here. No, I will not show you. It's okay. There is a way of recording a macro. Yeah? For example, there are macros that are done on default. What? There are macros that are done already on default, but you have to know programming. Me, I can program in 7 languages, so I don't have a problem. You can program, and good. Yeah? Me, I can program. I don't have a problem with programming. I program my own things. Yeah, so if you have to do that, you have to learn a TCO language, which is in Surpac. Okay? So if you can understand that language, you can edit it. Then make it your own preference. There is no video for that, for the TCL.